Unit 3. Is this screen visible to you? The students, please reply. Is this screen visible clearly?
Yes, ma'am.
Okay. Now today you are going to study about BODE plot. Okay. So in last lecture you have studied frequency domain specifications, right? Now today you are going to study about plot. Okay. So from unit 1, next topic, please give the heading. Unit 3, please give the heading. Unit 3, BODE plot. So before drawing BODE plot, I'm going to explain how to plot it. Okay. So before starting, you should know the objective of this session. So what is the objective of this session? Students, objective of this session is to construct BODE plot. Okay. And what is outcome? That is nothing but learning outcome or course outcome is to predict stability of system using BODE plot. Okay. So in unit 2, you have studied about stability of system. That is nothing but from location of poles. Okay. If your poles are located at left half of S-plane, that means your system is stable, right? Similarly here in unit 3, as you have studied frequency domain analysis, so in order to predict the stability of system, here we are going to use BODE plot. Okay. So this is nothing but objective of this session, and this is nothing but outcome of the learning outcome of this course, control system. Okay. So please be ready with notebook and pen, pencil. Give the heading BODE plot. Now students, today I am going to explain how to plot BODE plot. Okay. And from BODE plot, we are going to conclude whether our given system is stable or not stable. Okay. So give the heading BODE plot. Now before writing anything, please try to understand the concept of BODE plot, how to plot it. So in BODE plot, you have to plot two things. First one is magnitude plot and second one is phase plot. Okay. So what is that magnitude and phase plot? That I am going to explain over here. It's very simple actually. Okay. So let us start with. So the BODE plot or BODE diagram consists of two plots. Okay. First one is magnitude plot. Second one is phase plot. Right. Now in both the plots, x-axis represent your angular frequency omega on log scale, logarithmic scale. Okay. So you are going to use log paper, not ordinary ordinary graph paper, semi log paper. Okay. So you should have log paper with you, and on x-axis we are going to have angular frequency omega. Okay. So x-axis represent angular frequency, that is nothing but on the logarithmic scale, that you have to remember. Okay. Whereas on y-axis we are going to plot magnitude of the system. Okay. And that is linear scale. Magnitude is linear scale, but on x-axis we are going to plot the angular frequency with logarithmic scale, that you have to remember. That means 0.1 के बाद क्या आएगा 1 के बाद क्या आएगा 10 के बाद 100, like this. Okay. That is nothing but logarithmic scale. Okay. But on y-axis, we are going to take magnitude, and that is nothing but linear scale. Okay. Linear scale of open loop transfer function in the magnitude plot, and the phase plot is nothing but linear scale of the open loop transfer function in the phase plot. Chalo, ye ho gaya magnitude phase plot. So you are going to draw two diagrams in the BODE plot. First one is magnitude plot and second one is phase plot. So let us see, there are some standard rules, or you can say standard steps to draw the magnitude plot and phase plot. Okay. The equation you have to remember related to magnitude and phase is this. Okay. So the magnitude of the open loop transfer function in dB, that is nothing but decibel, is given by this equation. M is equal to, magnitude is denoted by letter M, capital M. So student, please write the equation for magnitude. M is equal to 20 log of mod of G of S into H of S. But here we are going to replace S by J omega, right? So our equation for magnitude plot, magnitude of the open loop transfer function in decibel is given by this equation. Capital M is equal to 20 log of 10. Base काय आहे 10, 20 log mod of G of J omega, H of J omega, okay, to the base 10. Base of logarithm is 10. Okay, so by using this equation, we are going to find magnitude of open loop transfer function. Okay, you will get that magnitude in dB, maybe in plus dB, maybe in minus dB. Okay, that depends on the given transfer function equation. Okay, now next one is nothing but your phase angle phase plot. So you have to find, you have to calculate phase angle. So how to calculate that phase angle? So you are going to calculate that phase angle by using this equation. So phase angle of the open loop transfer function is in degree, and that is given by this equation. Phi is equal to angle G of J omega, H of J omega, right? So you have to remember these two equations, students. So please write equation for magnitude before drawing the BODE diagram, and equation for phase angle. So these two equations you have to remember. For magnitude, M is equal to 20 log of mod of G of J omega into H of J omega to the base 10. And for phase angle, phi is equal to angle G of J omega and H of J omega. Please write these two equations in your notebook. प्रत्येक वेळेस आपल्याला काय करायचे, प्रत्येक टर्म्सला ट्रान्सफर फंक्शन मध्ये जेवढ्या काही टर्म्स असतील, फॉर ऑल दिस टर्म्स वी आर गोइंग टू फाइंड मॅग्निट्यूड अँड फेज, अँड देन वी आर गोइंग टू प्लॉट. ओके, पहिलं एक टॅब्युलर फॉर्म मध्ये, एक टेबल फॉर्म मध्ये आपल्याला मॅग्निट्यूड लिहायचं प्रत्येक कंपोनेंटचं आणि फेज लिहायचं प्रत्येक कंपोनेंटचं, राईट? अँड आफ्टर दॅट वी आर गोइंग टू प्लॉट द डायग्राम, अँड दॅट इज नथिंग बट BODE plot. Is this clear, students? Chalo, aage. Now these are some of the basic things that you have to remember while constructing BODE plot. So basics of BODE plot. So draw this table. All of you, please draw the table. Please write all the parameters. So first column is nothing but type of term. Second column is nothing but our transfer function, open loop transfer function, G of J omega into H of J omega, right? Then slope of that. Slope you will get in dB per decade. Always you will get slope of your line is in dB per decade, because we are going to use logarithmic scale on x-axis. Okay. Then in next column, please write magnitude. So you will get magnitude in dB, right? And that is nothing but you are going to calculate this magnitude by using that equation just I have given. Magnitude is equal to, right? What is magnitude is equal to 20 log of mod of G of J omega into H of J omega. That is nothing but magnitude in dB. And then you are going to calculate phase angle. So what is phase angle? Phase angle you will get in degree. So phase angle is equal to angle of G of J omega into H of J omega. Okay, so give all the headings and let us start with constant values. So all these are nothing but basic thing you have to remember related to BODE plot. Now consider in your open loop transfer function equation, there is a constant. Okay, so if the term constant is present in the transfer function equation for open loop, okay, open loop control system, then you are going to calculate magnitude and phase for that constant. Okay, So constant is denoted by letter capital K. Okay. So G J omega H J omega is equal to K. असं जर असेल आपल्या इक्वेशन मध्ये K कॉन्स्टंट जर असेल, so naturally the slope of that constant is equal to 0. That is nothing but 0 dB per decade. Okay. So always don't calculate again. Just remember this table. So you can plot the Bode diagram, right? So for constant, magnitude is equal to K. Slope of that constant is equal to 0, because what is equation? Equation is 20 log of K, log of K to the base 10. Okay. So this is the equation for magnitude. So 20 log of K into to the base 10. So what is slope? Slope is equal to 0. And what is phase angle? Phase angle is also 0. Phase angle is also 0 degree. Okay. So you have to remember, if you are having any constant term in the transfer function equation for open loop control system, that constant is nothing but K. Okay. Or any integer, can say 5 असेल, 9 असेल, जे काही असेल ते, that is K. Okay. Slope is equal to 0 dB per decade. You have to remember this. Then phase angle is equal to 0 degree. Got my point? हे दोन गोष्टी लक्षात ठेवायच्या. कॉन्स्टंट आला की मॅग्निट्यूड 0, फेज 0. ओके. आता पुढे, now in the transfer function equation there are zeros and poles. Okay. न्यूमरेटर मध्ये जे काही लिहिलेलं असतं मुलांना, that is zeros, and in the denominator what you have written, what are the terms? We are calling that terms as poles. Okay. आता बघूया, starting with zeros. Okay. Now first zero at origin. Suppose 0 is present at origin, right? Means S is equal to 0. So in frequency domain analysis, we are going to replace S by J omega, right? So G of J omega, H of J omega is equal to J omega only. 0 at origin means S is equal to 0, right? We are replacing that S by J omega. Okay. Now slope of this J omega is always equal to 20 dB per decade. This 20 is plus 20 dB, huh? Current these are zeros. 0 at origin. So slope is plus 20 dB per decade. That you have to remember, because magnitude is equal to 20 log of omega. Right? Magnitude is equal to 20 log omega. And what is phase? Phase is angle of J omega, G of J omega, H of J omega, angle of that. So angle of J omega is nothing but 90 degree, plus 90 degree. That you have to remember. आता या basic गोष्टी आहेत related to Bode plot that you have to remember while drawing the diagram, Bode diagram. Now next, n number of zeros at origin. Suppose next type of term is n zeros at origin. So at that time, what you have to do? You have to multiply with n. Okay. You have to multiply that number of zeros with n. Okay. So n zeros at origin. पहिलं काय होतं? फक्त एकच झिरो होता. 0 at origin. You have taken origin. 0 at origin. You have taken J omega. For n zeros at origin, you have to take J omega into n, multiply by n. Similarly here, for slope, 20 dB per decade into n. जेवढे number of zeros असतील, n zeros असतील तर into n. 4 zeros असतील तर into 4. So into 4 केल्यावर काय होईल? 80 dB per decade is nothing but your slope for 4 zeros at origin. Got my point? Okay. And J omega into n म्हणजेच काय येणार आहे आपलं? 4 omega येणार आहे. Okay. आता coming to phase angle. So yes, magnitude is nothing but 20 into n into log of n. Okay. So your magnitude is nothing but 20 into n into log of omega. Got my point? And phase angle is nothing but 90 degree again. zeros at origin आहे, zeros असेल तर 90 degree, number of zeros असतील तर you have to multiply with that number of zeros. Okay, so 90 into n, that is nothing but phase angle in degree. So this is how you will get magnitude and phase angle for constant, for zero at origin, for n number of zeros at origin. Okay, now coming to poles. Poles are at denominator, right? So if your pole is at origin, that means S is equal to 0. There असेल, if pole is at origin, at that time we have to take 1 divided by j omega, right? 1 by s म्हणजेच खाली आलं ना डिनॉमिनेटर मध्ये. So you have to take pole at origin 1 divided by j omega. We are replacing s by j omega in frequency domain analysis. आता बघा स्लोप काय झाला त्याचा. What is slope of that pole? Slope is nothing but minus 20 dB per decade. What is the equation for magnitude? Minus 20 log of omega to the base 10 is nothing but magnitude, right? Then you are going to calculate the value of magnitude by just changing the value of omega. Okay. Then phase angle is equal to 0 ला phase angle काय आहे? 0 at origin असेल तर phase angle is 90 degree, but pole at origin, at that time your phase angle is 90 degree with minus sign. Okay, or this minus 90 degree you can call this as 270 degree positive phase angle. Got my point? When pole is located at origin. Now if number of poles at origin are available in your equation, then what happened? How to calculate the magnitude and phase? Suppose n poles at origin are present. So n poles means you have to multiply by n. So 1 divided by j omega into n. What is slope? Slope is nothing but same, minus 20 dB per decade into n number of poles. 5 poles at origin असतील तर काय करणार आपण? Minus 20 into 5. Okay, and how to write magnitude? Magnitude is equal to 20 into n log of omega. This is the equation for magnitude. And what is phase? Phase is again minus 90 degree into number of poles. 5 आहेत तो into 5. So किती झालं phase angle? 9 into 5, 45, 450 phase angle in degree. Okay, or you can write like this also, 270 into n. Do the calculation, and that is nothing but, that much is nothing but your phase angle in degree you will get for n poles at origin. So student, you are supposed to write this table and you have to remember always while drawing the BODE diagram, while drawing the BODE plot. So this is nothing but basic thing you should know about BODE plot. Any doubt up to this? Any doubt, students? No doubt. Okay. Now, starting with constant. आता हे मी जे तुम्हाला सांगितलंय ना, starting with constant, 0 at origin, I am going to draw BODE plot for this. All these components, all these terms. Okay. So first I will take constant, then I will take 0 at origin, then n zeros at origin, then pole at origin, then n poles at origin. So student, all of you, please write this table. हे सगळं लक्षात ठेवायचं आहे तुम्हाला. मॅग्निट्यूड काय असतं, फेज काय असते. ठीक आहे. These two columns are important for all these terms. These are the terms included in the equation of transfer function for open loop control system, right? So let us start with first term, that is nothing but constant K. First term is constant K. So what you got in constant K, that I am going to explain. For constant K, j omega is equal to K. Slope is 0. Magnitude is 20 log of K to the base 10. Phase is 0. Same thing is available over here. Okay. But how to plot? how to plot the diagram. So for constant k, you have to consider open loop transfer function. So open loop transfer function is equal to k, that is constant. Okay. So what is the equation for open loop transfer function? You can write open loop transfer function like this: g of s into h of s is equal to constant k. Okay. Now you have to plot magnitude and phase angle. Magnitude plot and phase angle plot. Two plots you have to plot for this constant k. How to do this? Same again. Find out magnitude, find out phase angle. So how to find magnitude? Yes, 20 log of k to the base 10 is nothing but magnitude, right? So please write the equation for magnitude m, capital M. So capital M is equal to, this is the equation, open loop transfer function. Okay, g of s, h of s is equal to k. So now you are going to write the equation for magnitude and angle. Kutla angle? Phase angle. Okay. So m is equal to 20 into log of k to the base 10. So you will get your magnitude in dB, right? So please write first equation for magnitude. Have you written the equation for magnitude? Okay. Now write the equation for phase angle. Phi is equal to 0 degree. That is given in the table, right? That is given in the table. Now, for different values of k, let us see what is value of magnitude, and accordingly we are going to plot the magnitude plot and phase plot, right? Suppose on x-axis we are going to take log of logarithmic scale of angular frequency omega, so log omega on x-axis, and magnitude in dB on y-axis. So right on y-axis we are going to plot. So please plot it. Now take k is equal to 1. So for k is equal to 1, what is m? M is 0 degree, k is 1, right? Log of 1 to the base 10. If k is equal to 1, then magnitude is equal to 0 dB, right? If k is greater than 1, then magnitude will be positive, right? Jayu, 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 Jayu. आवाज खूप येतोय. So if k is greater than 1, then magnitude will be positive, right? So if k is equal to 1.5, k is equal to 2, greater than 1 असेल तर काय येणार आहे magnitude? Positive येणार आहे आपल्याला. Take log of that into 20. So you will get positive value when value of k is greater than 1. Now when k is less than 1, okay, k less than 1 असेल म्हणजे अगदी 0.9 असेल, 0.5 असेल, so less than 1, right? So if the value of k is less than 1, then magnitude is negative. Okay, so that you have to remember. That you will get over here. Okay, k is equal to 1%, you will get 0 dB. K is equal to 2%, you will get some positive value. Okay, k is equal to 0.5%, you will get negative value itself by using this equation 20 log of k to the base 10. Okay. आता आपण ड्रॉ करूया ह्याचा. See, now this is nothing but your BODE plot for magnitude. Okay, magnitude plot. आता बघा, k is equal to 0 असेल, sorry, k is equal to 1 असेल तर काय आलं आपल्याला 0 dB. So my 0 dB line is here. This is my 0 dB line. So this line is nothing but my 0 dB line. Okay. At that time, K is equal to 1. Or you can say K is equal to 1. You will get magnitude is equal to 0. So you can plot one line like this. असं प्लॉट करूया आपण. ही लाईन आपण प्लॉट करूया. ही लाईन झाली माझी. K is equal to 1. At that time, magnitude in dB is equal to 0. ओके. या 0 ला एक लाईन आली माझी. आता दुसरा मॅग्निट्यूड प्लॉट काढायचा मला. व्हेन K is equal to 1. K is equal to 1 असेल, सॉरी, K is equal to greater than 1 असेल तर काय येणार आहे माझा? Magnitude will be positive. So positive is in this direction. Okay. या डायरेक्शनला काय आहे माझं? पॉझिटिव्ह आहे, राईट? पॉझिटिव्ह अँप्लिट्यूड आहे या डायरेक्शनला. या डायरेक्शनला काय आहे माझं? निगेटिव्ह अँप्लिट्यूड आहे, राईट? So when the value of K is greater than 1, at that time you will get positive value of magnitude. So I am drawing this line. This is nothing but one line starting from this point. Y axis पासून start करायचे. So this is nothing but my line with magnitude is equal to 20 log K. काय आहे मॅग्निट्यूडचं इक्वेशन? 20 log K. ओके. आता K ची व्हॅल्यू ग्रेटर दॅन 1 आहे, म्हणजे 2 आहे समजा, 1.5 आहे. ऍट दॅट टाइम आय एम हॅव्हिंग पॉझिटिव्ह व्हॅल्यू ऑफ मॅग्निट्यूड. सो फॉर दॅट आय हॅव ड्रॉन द मॅग्निट्यूड प्लॉट. दिस इज नथिंग बट माय मॅग्निट्यूड प्लॉट. एक सिंगल लाईन म्हणजे मॅग्निट्यूड प्लॉट आहे. सो डोंट ड्रॉ विथ एरो, जस्ट ड्रॉ ए सिंगल लाईन, स्ट्रेट लाईन. सो दिस लाईन इज नथिंग बट माय magnitude plot. Got the point? For K is greater than 1. Now when K is less than 1 or varying between 0 to 1, less than 1 means what? Greater than 0 and less than 1. So at that time I got magnitude is equal to negative value, negative dB. Okay. So I have drawn this line. Now this is the line for K is less than 1 or K is varying between 0 to 1, right? At that time, what is magnitude? Magnitude is nothing but minus 20 log of K. Got my point? Now this is how you can plot the magnitude plot. Okay. BODE diagram मध्ये magnitude plot कसा draw करायचा समजलं? Magnitude plot is nothing but just a horizontal line with some dB, right? Magnitude plot is nothing but a horizontal line, and that is not dependent on any frequency component, right? The 0 dB line, this is 0 dB line. The 0 dB line itself is a magnitude plot. Okay. He ji line आहे 0 dB line is nothing but your magnitude plot. This line is nothing but your magnitude plot with positive dB. This line is nothing but your magnitude plot with negative value of magnitude. Okay. समजलं का मुलांनो? परत एकदा सांगते. When the value of K is 1, the 0 dB line is nothing but magnitude plot. The 0 dB line is nothing but magnitude plot when the value of K is 1. Now for positive values of K, K ची व्हॅल्यू जर पॉझिटिव्ह असेल तर काय होतंय? हॉरिझॉन्टल लाईन शिफ्ट होते in the upward direction, that is nothing but in the positive direction above 0 dB line, above 0 dB line. आता K ची व्हॅल्यू जर कमी असेल किंवा निगेटिव्ह व्हॅल्यू असेल K ची, तर काय होतंय? ही जी हॉरिझॉन्टल लाईन आहे that is shifting from 0 dB to downward direction or below 0 dB line. Okay. So the 0 degree line itself is a phase plot. Okay. Ata phase plot. This is magnitude plot. Okay. BODE diagram मध्ये दोन प्लॉट काढायचे असतात तुम्हाला. First one is magnitude plot. So you have drawn magnitude plot for this open loop transfer function g of s into h of s is equal to k. ओके, झालं मॅग्निट्यूड प्लॉट झाला आपला कंप्लीट, फिनिश. आता फेज प्लॉट. आता फेज प्लॉट साठी काय करायचं आपल्याला, एक्स ऍक्सिस ला काय घ्यायचं आपल्याला, अँग्युलर फ्रिक्वेन्सी इन logarithmic scale. Okay, so log omega. So take log omega on x axis and degrees or phi on y axis. Okay, so the 0 degrees line, this 0 degree line, this is suppose a line with 0 degree. Okay, he baga ithe, this is the line, this is the line with 0 degree is nothing but your phase plot for all the values of k, positive values of k. Got my point? So you can write like this, your k is varying between 0 to infinity. That means all the values, positive values of k, you will get degree is equal to 0. So this is the plot, phase plot. Ha jo zhala ha, this is the phase plot. The 0 degrees line, this is the 0 degree line. It is 0 hai na? On x y axis I have taken phi in degrees. So at this point I am having 0 degree. Okay, so this 0 degree line itself is the phase plot for all the positive values of k, means greater than 0. Got my point? And this is nothing but your phase plot. So ha jo kahi ahe mulanno, this one is nothing but your, oh sorry, just a second. So this is nothing but your magnitude plot for this given transfer function. Okay, and this is nothing but your phase plot for given open loop transfer function. Okay, so g of s into h of s is equal to k. Got my point? चला आता पुढे. Any doubt up to this? Now this information I have taken from this basic table. This is the basic table. Okay, so for constant k is equal to for constant is nothing but k, magnitude plot is 20 log of k, and phase is 0 degree. First plot केला अपन. Now 0 at origin. चलो start करते हैं आगे वाला. So this is what about constant k. Now 0 at origin. Next. Same thing again you are going to draw. Zero at origin. So consider the open loop transfer function again. So this is the open loop transfer function. G of s into h of s is equal to s. Now find out magnitude and phase. How to find magnitude? Magnitude is equal to m is equal to capital M is nothing but magnitude. M is equal to 20 log of omega. Because in frequency domain you have to replace s by j omega. So take log of omega to the base 10. To the base 10. So magnitude is equal to 20 log of omega to the base 10. Find out. For different values of omega, you will get magnitude, right? Now, phase angle phi is equal to 90 degree, that is given in the table. So no need to find out the phase angle. That is given. Standard phase angle for S is equal to 90 degree. 1 divided by S astel phase angle minus 90 degree. So that you have to remember. No need to calculate again. Chalo. Abhi different values of omega angular frequency, you will get magnitude. Now let us see how to calculate that magnitude. So you are having equation for magnitude, m is equal to 20 log of omega to the base 10, right? Now put omega is equal to some different value. Initially logarithm scale ahe mulanno. So initially you are having 0.1, omega is equal to 0.1. So put omega is equal to 0.1, then omega is equal to 1, then omega is equal to 10. 100 and so on. You will get magnitude plot, right? चलो अभी start करते हैं. At omega is equal to 0.1 radian per second. The unit for angular frequency is radian per seconds. Okay. So put omega is equal to 0.1 in this equation. Now take 20 log of 0.1 to the base 10. You will get magnitude is equal to minus 20 dB. Means काय -1 येणार. Okay. So magnitude is equal to minus 20 dB. Right? Then put the value of omega is equal to 1. Put the value of omega is equal to 1 radian per second. You will get magnitude is equal to 0. Log of 1 to the base 10 is 0. So magnitude is equal to 0. Right? आता पुढची व्हॅल्यू टाका ओमेगाची. Angular frequency omega is equal to 10 radian per seconds. Okay. So put this 10 radian per second in this equation. So magnitude m is equal to 20 log of 10 to the base 10. Log of 10 to the base 10 is equal to 1, right? Into 20. So we'll get magnitude is equal to 20 dB. Are you with me? Magnitude is equal to 20 dB. Okay. Now, from these three statements or from these three values of magnitude, we are going to plot the magnitude diagram. Magnitude plot draw करणार आहोत आपण. So again, on x-axis, I have taken log omega. So this is my log omega on x-axis and magnitude on y-axis. M in dB, magnitude in dB, and logarithm scale of angular frequency, that is log omega, right? Ata first, now at this point omega is equal to 0.1. At this point omega is equal to, just wait, I'm going to draw. At this point omega is equal to 0.1. At this point omega is equal to 1. At this point omega is equal to 10, and so on, right? Logarithm scale आहे. आता काय करायचं आपल्याला बघा. So at omega is equal to 0.1, what is magnitude? That we are going to draw in the magnitude plot. बघा आपण draw करणार आहोत आता. Are you with me up to this? Now take the graph paper, semi-log paper, and plot. At omega is equal to 0.1, what is magnitude? Magnitude is equal to minus 20 dB. Okay, so this is 0 dB line, right? ये जो line है, this is 0 dB line. Okay, नहीं? ये जो line आली है, no. This line is for 0 dB. Okay, 0 dB line झाला. 0 नंतर काय येणार आहे? 10, 20 किंवा 20, 40, 60. Okay, plus 20, plus 40, plus 60. On this side, minus 20, minus 40, minus 60, and so on. आपली काय आली magnitude ची value? Magnitude is equal to minus 20 dB. So you can draw the line from this point. Minus 20 dB is here. Okay. So this is nothing but minus 20 dB. Okay. Next is minus 20 dB म्हणजे slope काय जाणार आहे? असा जाणार आहे. Plus 20 dB असता तर slope काय आला असता? असा आला असता, right? So this is nothing but line. Then next. Yes, are you with me, students? We are drawing magnitude plot. So magnitude plot is nothing but again a line, okay, which is having slope of 20 dB per decade. Okay, this line is starting from this point at omega is equal to 0.1 radian per second. This is nothing but 0.1. This is nothing but 0.1 radian per second. So our magnitude plot is starting this line. Magnitude plot is nothing but line. So this line is started at omega is equal to 0.1 with slope of 20 dB. Okay, so this is my line with slope of 20 dB. Now my line is crossing. My line is crossing this point. Which point? Omega is equal to 1. Now omega is equal to 1 जेव्हा आहे. So this line is nothing but line of 0 dB magnitude, right? So it is touching, or you can say crossing this line. कुठली line? 0 dB ची line cross करती है at omega is equal to 1. Okay. And the slope is continue in nature. बघा हा जो slope आहे that is continuous. So this line is started from 0.1 at 20 dB slope. Okay, and it is continuous with that slope. Continuous with that slope. But here this line is crossing this point. This point is nothing but at omega is equal to 1 radian per seconds. Okay, and this line is 0 dB line. Okay, now this is nothing but your magnitude plot. आता फेज बघूया आपण. हा झाला तुमचा magnitude plot. बस for given transfer function. This is the magnitude plot. हो गया. अभी क्या करना है? फेज प्लॉट करना है. Are you with me, students? आता जर S असेल आपला टेबल बघा परत. For S, what is phase? Phase is 90 degree. Go back again to table. Always you have to refer your table. Table मध्ये बघा काय आहे. For S, what is phase angle? Phase angle is 90 degree. चलो अभी phase angle 90 degree करते हैं. So now in this case for 0 at origin, the phase plot is nothing but 90 degree line. So coming to this phase plot, so take your phase, that is angle in degree. So this is nothing but on y-axis take phi in degree, on x-axis take angular frequency, that is logarithmic scale of angular frequency log omega. Okay, and phase plot is nothing but this line. Phase plot is nothing but this line. Just wait. Line with 90 degree. This is the line with 90 degree. Is nothing but phase plot. ठीक है. हे आहे 0 degree. हे आहे 0 degree. या लोकेशन ला आहे 90 degree. So what is phase plot? For S only, because transfer function is S. So for S, phase angle is 90 degree plus 90 degree. So I have drawn the phase plot. Is nothing but again line. Arrow nahi ha. मी दाखवले तुम्हाला. Phase plot is nothing but line at 90 degree. Here 90 degree आहे. So the second one is nothing but your phase plot for given transfer function. हा जो आला हा काय आला तुमचा phase plot आला. Got my point? So this is how you have plotted BODE diagram or BODE plot. First one is nothing but this one is nothing but your magnitude plot, and second one is nothing but your phase plot for given open loop transfer function g of s into h of s is equal to s. Okay, second condition बघितली आपण. आता थर्ड कंडिशन बघूया. काय राहिले आता? चलो आगे चलते हैं. Now next, student, you are supposed to write with me. Next, poles. Pole at origin, single pole at origin. Okay. आपल्या डायग्राम मधला थर्ड पॉइंट. 0 बघितला at origin. आता जर pole at origin असेल तर how to draw the Bode plot? That you are going to study over here. So consider the transfer function. Over the transfer function g of s, h of s is equal to 1 by s. Okay. Equation for magnitude is equal to pole is equal to minus 20 log of omega to the base 10. Equation for phase angle phi is equal to minus 90 degree. That is given in the table. Okay. Here also you have to put different values of angular frequency omega is equal to 0.1, 1, 10 and so on. You will get different values of magnitude and plot. So pole at origin, your transfer function is 1 by s. Replace s by j omega. So you will get 1 divided by j omega, pole at origin. So magnitude is equal to minus 20 log of omega to the base 10 and angle is equal to phi is equal to minus 90 degree. That is given in the table, standard form. Now find out omega, find out magnitude for different values of omega. Angular frequency is equal to 0.1 radian per second. Put this into this equation. You will get magnitude is equal to, आता पहिलं बघा प्लस असताना काय मिळालं होतं आपल्याला मायनस. आता इथे काय आहे, when you are going to put omega is equal to 0.1 in this equation, you will get minus 1 येत आहे ना, बरोबर. That minus 1 into minus 20 is plus 20. So the magnitude is plus 20 dB when omega is equal to 0.1 radian per second. Then take next second value, omega is equal to 1 radian per second. So log of 1 to the base 10 is nothing but 0, right? So magnitude is equal to 0 dB. Then next equation, take omega is equal to 10. So omega is equal to 10 radian per second. So what is magnitude? Minus 20 log of 10 to the base 10. Log of 10 to the base 10 is equal to 1 into minus 20 is equal to minus 20 dB at omega is equal to 10 radian per second. Okay, so you are having magnitude when omega is equal to 0.1 is equal to 20 dB plus 20 dB. minus 1 आणि minus 20 plus 20 dB. जेव्हा ओमेगा 1 radian per second असेल त्यावेळेस काय असतं मॅग्निट्यूड 0. ज्यावेळेस 10 radian per second असते त्यावेळेस काय असतं मॅग्निट्यूड minus 20 dB. आता with this data you are going to plot the magnitude plot. आता कसं काढायचं magnitude plot बघा. X axis वर log omega, y axis वर magnitude. Starting with omega is equal to 0.1 radian per second. So 0.1 radian per second at that time magnitude is 20 dB. So your plot is starting from this point 20 dB. Okay, then omega is equal to 1, magnitude is 0 dB. So this is nothing but 0 dB line. So your plot is crossing at omega is equal to 1 with the same slope. Okay, what is magnitude at omega is equal to 10? Magnitude is equal to minus 20 dB. So this is how you can plot the magnitude plot. So starting with plus 20 dB when omega is equal to 0.1, right? Then when omega is equal to 1, magnitude is equal to 0. So this is 0 dB line, this is 0 dB line. Okay, this is 0 dB line. When omega is equal to 10 radian per second, at that time magnitude is equal to minus 20 dB, right? So you can draw this line काढायची मला. So at omega is equal to 10, amplitude is equal to minus 20 dB per minus 20 dB. Okay, and this is nothing but your plot starting from plus 20 dB. Okay, with the slope plus 20 dB crossing the line 0 dB at omega is equal to 1, then continue with same slope of minus 20 dB up to omega is equal to 10 radian per second. So this is nothing but your magnitude plot. Now, any doubt up to this? Student, any doubt up to this? Now, what is phase? Now, when pole is at origin, at that time, phase angle is minus 90 degree from table. So on x-axis, I have taken log omega. On y-axis, I have taken pi in degree. But when pole is at origin, at that time, your phase angle is minus 90 degree. Okay. So below this 0 degree line, I have drawn one line parallel to that. Okay. And this is nothing but my minus 90 degree. So this is the phase plot. Ha jo plot ahe, that is nothing but phase plot. Phase plot for given open loop transfer function, and this one is nothing but your magnitude plot. Okay. So magnitude plot is a line. This is a line. Magnitude plot is nothing but a line. Okay. Which is having slope of minus 20 dB. Ha slope कितीचा आहे? Minus 20 dB per decade. Per decade का म्हणतोय? Because from point 1 to 1 there are 10 lines in your semi-log paper, and hence we are calling this as minus 20 dB per decade. Okay. Now this line is starting from omega is equal to 0.1 radian per second, having the magnitude minus 20 dB. Okay. And it is continue with the same slope. हा slope change होतोय का? नाही. तेवढा slope राहतोय. आता काय होतंय की इथे क्रॉस होते 0 dB line ला. This is 0 dB line and omega is equal to 1. And continue with the same slope up to omega is equal to 10. At omega is equal to 10, magnitude is equal to minus 20 dB per decade. So this is nothing but your magnitude plot, and this is nothing but your phase plot for pole at origin. Got my point? Understood? Now next, real zero. What is real zero? Again, same procedure. Real zero के क्या है? Consider the open loop transfer function g of s h of s is equal to 1 plus s into tau. This tau is nothing but time constant, RC time constant. Huh? Okay. Then find out magnitude, find out phase. So magnitude m is equal to 20 log of under root of 1 square real term square plus imaginary term square. Imaginary का म्हणते because we are going to replace s by j omega. Okay. So omega square p square. ये पूरा अंडर रूट में है. हाँ, दिस इज अंडर रूट. Under root. Okay, so student, please write equation. Magnitude is equal to 20 log of under root 1 plus omega square tau square to the base 10. Unit is in dB. For phase angle phi is equal to tan inverse of omega tau divided by 1 is nothing but omega tau. Phase angle is in degrees. Okay. Now for different omega, you will get magnitude as well as phase angle. Okay. Just by putting the value of omega in these two equations for magnitude and phase angle. Now for omega is equal to less than 1. Now this for omega less than 1 divided by tau omega less than 1 divided by tau, the magnitude is 0 dB. Okay. And phase angle is also 0 degree. You have to calculate this. I have written over here directly. For omega greater than 1 divided by tau, omega greater than 1 divided by tau, the magnitude is 20 log of omega tau to the base 10 in dB, and phase angle is 90 degree. that you have to write all these sentences from table, standard table. Then the figure here, it shows you magnitude plot and phase plot. Okay, so the magnitude plot is having magnitude of 0 dB, okay, up to omega is equal to 1 divided by tau radian per second. From 1 divided by tau radian per second, it is having a slope of plus 20 dB, slope of plus 20 dB per decade. So इथून जो स्टार्ट होतोय स्लोप कसा आहे, प्लस 20 dB आहे म्हणून या डायरेक्शनने इन्क्रीज होत आहे. मायनस 20 dB असता तर या डायरेक्शनने आलं असतं, राईट. सो the magnitude plot is having magnitude of 0 dB up to omega is equal to 1 by tau. ठीक है, इथून पुढे काय होत आहे, from omega is equal to 1 by tau, it is having slope of plus 20 dB per decade. Okay, हा जो slope आहे लाईनचा, it is a line with slope of plus 20 dB per decade, right? Now in this case, the phase plot is having phase angle of 0 degree. So this is the 0 degree plot up to omega is equal to 1 divided by tau. येतंय लक्षात? So the phase plot is having phase angle is equal to 0 degree up to omega is equal to 1 divided by tau radian per second. And from this point, it is having phase angle is equal to 90 degree. So इथे 90 degree आहे, मग phase angle 0 to 90 degree change झालाय बघा. तो कुठपर्यंत होत आहे, up to omega is equal to 10 divided by tau, because the slope of this line magnitude is plus 20 dB per decade up to this point. Omega is equal to 10 divided by t, and hence angle is plus 90 degree. So this is how you can draw the magnitude plot. This is your magnitude plot, and this is nothing but your phase plot for real zeros. For real zeros. Got my point? Any doubt up to this? Student, any doubt up to this? No doubt? Okay, thank you, students. Please write your attendance in chat box, then you are free to move. So we'll see remaining part, that is nothing but rules of construction of BODE plot. Then about stability, you have to study. Small part is remaining. Okay. So we'll stop here up to real zeros. Thank you, students. Please write your roll number in chat box with understanding. Then you are free to know. Thank you all. Good morning, students. Am I audible? Hello? Is this any doubt, students?
No, ma'am.
Okay, beta. Thank you.